Well, I'll go over this with you. For those of you that are working on going to do the second look, you want to make sure your summary page is well set up. So, density equals this. Actually, I think I did this with, I'll go ahead. That's what the density is. Volume, that's what you're trying to find. It's either milliliters or cubic centimeters. And 150 grams, that equals mass. So we're given mass, we're given density, we got to find volume. And density is mass divided by volume. Make sure I'm on the page. We're looking for volume. We got to do mass divided by density. V equals m over d. Substitute in the mass is 150 grams. The density is 11.35 grams per milliliter. Okay, so there you go. Put that in your calculator. Now on the test, several times we might have said whatever your answer is, round it to 1 decimal point. So, well, actually, okay, so I have a calculator here. Shoot, thought I had a calculator. And I don't. I'll do it on the next one. So, gold has this for number 2 now. So it's telling you this is the density, and on your papers you need to annotate that. How many grams? Grams is mass. So we're trying to find mass, and it tells us we got 7 cubic centimeters. That's volume. If you don't know a cubic centimeter is a volume, milliliters or centimeters cubed. Maybe have that on your summary page. Volume is equal to, oh wait, I'm sorry. We're looking for mass this time. So mass, I'm going to cover that up there. It's D times V. Mass equals D times V. Now we're just going to substitute in 19.3 grams per cubic centimeter. And let's see now. The volume is 7 centimeters cubed. You multiply that out, and let's see. Let me get a calculator here. Let's see. Let's do 19.3. Whoops. Make that 19.3 times 7. Okay, I got 135.1. I don't know. Let me double check. Always double check. 19.3 times 7. Always double check your calculations. Okay, I got the same thing. So, there we go. On this one up here, let's see. I'm going back to number 1. 150 grams divided by 11.35 equals. So in my calculator, I got 13.215. Now, if the test is asking you to round it to 1 decimal place, since this number here is less than 5, if it's rounded to 1 decimal place, your answer would just be 13.2. If we asked you to round it to the 2nd decimal place, we got to round it here. Since this number is 5 or bigger, we would make this like that. Ignore that one. Your answer, if it was to 2 decimal places, 13.22. All right, number 3. We're trying to calculate the density of the rock. Density is mass divided by volume. It tells us what the mass is right away. Let me make sure we're centered here. Get back over there. Okay, you just plug it in. 27.2 grams. Now the mass here, okay, they're telling us that we had a graduated cylinder that had 35.5 milliliters to start. And then we added into here some water, and it went up to here, and that's going to be 52.0. So we got to subtract that, because after we put the rock in, the water level went up. And we got to subtract those two numbers. 52 minus 35.5 equals 16.5 milliliters. 16.5 milliliters. Now you do your math with your calculator. But always show the equation you're using and then substitute in the values. Okay, we've got a box that's these dimensions and this thickness. Oh, I'm sorry, this is the mass, 10 grams. Oh, now to find the volume, volume will be length times width times height. And so let's see, we'll do 6.2 times 1.9. let me do this so we don't get those, times 1.9 times 0.5. So let's see, 6.2 times 1.9 times 0.5 equals, I got the volume equals 5.89. Now here it says rounded to 1 decimal place. So I'm going to round this answer to 1 decimal place. Since this is bigger than 5, our answer becomes 5.9. And this was centimeter times centimeter times centimeter, so that'll be a centimeter cubed. We're not done. We got to do density because we're looking for density. Density equals mass divided by volume. That was right up here. It's on the top of the test. Now the mass was equal to 10.3 grams. We figured out this is 5.9 centimeters cubed. You got to divide this number divided by that, and remember, whatever the answer is, round it to 1 decimal place. Okay, this question was kind of a problem for students, but it shouldn't have been. These particles are representing how heavy it is. There's 1, 2, 3, 4, 5, so the mass would be 5, whatever the unit is. Over here, the mass is also 5. Now, the volume, okay, so density is always mass divided by volume. So I'm just going to look at the square. This square looks like it's, actually I'm going to say this square looks like it's about twice one of those. I mean, there's a lot more volume. The volume is bigger here. If I say volume equals, okay, I'm just going to say volume equals, it's this big. And over here, the volume equals, it's like almost twice as big. The volume is a lot bigger. So what happens is, if you were to do a calculation here, there's 5 particles in here. Let's say the volume is 1. 5 over 1, 5. Over here, the mass is still 5, but this is about, I don't know, is that twice as big? I'm just going to say, what if it's twice as big? Or heck, even if it's 1.5 times as big. Maybe you think, no, I think it's 1.5 times as big. Okay, well, what happens is, no matter what you did on there, whether you did 5 divided by 1.5, or if you said, no, I think it's twice as big, 5 divided by either one of those numbers, it's going to be less than 5. It's going to be around 2.5 to maybe 3. So, because this has such a big volume, there's a lot more air spaces if you want to think. They both weigh the same, but this is bigger. This is going to be lighter. This maybe is like styrofoam compared to a piece of wood. Over here now, how many neutrons in each atom? So we got to round this to 11, and 11 minus 5 neutrons equals 6. 12 minus 6 equals neutrons are 6. 14 minus 7 is 7. Neutrons equals 7. 16 minus 8, I think that's 8, isn't it? 8 and 8, 16. Yeah, neutrons equals 8. Okay, this is 19 when we round it off. 19 minus 9 is, let's see, 10. Neutrons equals 10. Over here, 20 minus 10. Neutrons equals 10. So, for us, we just answered this. On the test, there's a different question. I don't know if it asks you which one has 6 or which one has 7 or which one has 10 or what is, but that's how you do it. Just because this number tells you how many particles, it tells you the protons plus the neutrons. And this is the, and you know what? Yeah, I'm sorry. This is the atomic number. They switched it around, okay? Normally they're on the top and the bottom, but you just subtract the two numbers. Which of these describes the atom, or which of these is not correct? Well, first off, I'm just going to draw an atom and you figure it out. The atom has a little tiny nucleus that has plus charges and zero charges, neutral charges. And then it's really dense and heavy. And then the electrons are just spreading out way huge on here. So you kind of decide the electrons, they have negative charges out here. The protons give this a positive charge. They're super close together. But you can go through and figure out, because you know, protons and neutrons have mass, electrons are very low mass, super lightweight. All right, this one right here. Draw the correct Bohr model for beryllium +1 ion. Well, okay, I'm just going to do plain old beryllium to start with. On your periodic table, beryllium has 4 protons and 4 electrons and 9 particles in the nucleus. So I'm just going to start with the regular one. I'm not going to ionize it, just do the first one. So I need to have 4 protons in the nucleus, so 1, 2, 3, 4. And then now I got to figure out neutrons for beryllium. I'm going to do, let's see, 9 minus 4 is going to be 5 neutrons. 1, 2, 3, 4, 5. Okay, I've drawn the nucleus. Now I got to draw the shells. Beryllium's in the second period, so it has 2 shells. So I'm going to go ahead and draw a dotted line for the first shell and the second shell. Now normally, we'll ionize it in a second. Beryllium has 4 electrons because every proton attracts an electron. So this is what it would look like, 2 there and then 2 here. Okay, but now this is beryllium plus ion, which means it had to lose one of these electrons. So, and it's just a plus one. If it was plus plus, it would have lost both of these, but this problem says it just lost 1 electron. So I'm just going to erase one of the electrons in the valence shells. And now over here, this would be what beryllium looks like, and beryllium plus 1 ion. So I think on the test it's a different one. Ions are formed by a neutral atom. Neutral atoms they have the same number of protons and neutrons. They either throw away electrons, they lose an electron, or that atom, if it's a nonmetal, it takes an electron. Oh, takes an electron. Sorry about that. That's what ions are. You can find that out if you ask your phone. Isotopes are formed by, atoms gaining electrons. Neutrons. We're adding neutrons to atoms to make them heavier. It doesn't change their atomic number. It doesn't change their charge. So you can either add neutrons to make an atom heavy, or you can have an atom and you take away neutrons. They fall out. This is what happens with when radiation occurs. A lot of radiation are neutrons falling out. So isotopes are formed by gaining neutrons or losing neutrons. Which region of the atom, which atom regions, what up the most, least? Oh, that's supposed to be take up the most and least space. Well, you know what? I just drew a diagram here. So here's the nucleus, here's the shell way out here. You figure that out. You should have a diagram of that. So there you go. And what does the periodic table's zigzag line? Oh, I can't believe you guys missed this. It separates the metals from the nonmetals. Okay, so the left side is metals, the right side's nonmetals. Yeah, there's a few in here that are going to be metalloids, but I don't think the question was really asking that. So anyway, there you go. I'd also recommend you go to my website calendar and you go look at, it was the date that we had the weird schedule. Let me go back to, go on the calendar to October 16th. And you can watch that review video of all the test review questions. Bye.